Hi everybody, today we want to talk about section 5.1, starting out chapter 5. But before we do that, we want to write the slope-intercept form of a line. I may not have said this to you guys, but the y equals mx plus b is called the slope-intercept form. So the reason it's called the slope-intercept is because we have our m, which is our slope, and our b, our y-intercept. So that is what we refer to as the slope-intercept form. Something that will be useful to us throughout this chapter, so make sure you know that that's what that's called. Today what we're going to do is we're going to talk about writing equations in that slope-intercept form. So last chapter I gave you the formula, or I gave you the equation and you graphed it. Now I could do things like this: write an equation whose slope is -2 and y-intercept is 5. Well, again, remembering that we use the form y is equal to mx plus b, where m is our slope, b is our y-intercept, we just plug in what we know. So y is going to be -2x plus 5. So just plug that in, that 2 in there, and the 5 in there, and we've got it. Another way that I could show this to you is I could write the equation of the line shown here, give you this graph. So there's a couple different ways we can do this. The first, we need, first of all, y is equal to mx plus b. So we need to find our slope, we need to find our y-intercept. So we could use our slope formula, or we could use our rise over our run. So if I start down here at 0, -4, I go up and over to 2, 0. So I rose 4, I ran 2. So my rise over my run is going to be 4 over 2, which is just 2. I don't necessarily need to use those 2 points. I can use any 2 points on the line. So what I could do is I could look at this point here, which is going to be 1, -2. Same idea. I go up 2, right 1, 2 over 1. My rise is 2. My run is 1. And that's going to give me that slope of 2. So it doesn't have to just be the 2 highlighted points. You can use any 2 points that are on that line. My advice is pick points that are easy for you. Don't pick this guy right here where it's 1.5, 1 maybe, probably 1.5. But just try not to have to guess as much as possible. Pick numbers that you know, like 1, -2, or 2, 0. Now we know our slope, so we can write y is equal to 2x, and our y-intercept, well, hey, it crosses the y-axis right there at 0, -4, so my y-intercept is -4, so I could write -4 or plus -4. Either one would work. So California, or in 1990, California had a population of about 29.76 million. During the next 15 years, the state's population was expected to increase by an average of about 0.31 million people per year. So they tell you that linear functions can approximate population change. Linear function is just the equation of a line. So we want to write a linear equation to approximate the expected population of California in any year between 1990 and 2005. we're going to use the information from that photo to help us out. So, still using y is equal to mx plus b. So, if you see this word per or the word rate, those are going to be keywords to tell you that this number right here is going to be your slope. So you can plug that in. And now our y-intercept, you can think of it as the starting point of your graph. But where are we starting at in this particular situation? Well, we're talking about the population change. So the starting population that we have at year 0 is this 29.76 million. That is going to be our y-intercept. So our equation of our line that we're going to write is y is equal to 0.31x plus 29.76. We're going to use the equation to predict the population of California in 2005. So we need to figure out how many years after 1990 2005 is. You guys may be able to figure this out in your head. If you can't, you just take 2005 minus 1990 and find out that that is 15 years. So that is the number that we're going to use for x. That's just going right up in there into our equation that we just wrote. So I'm going to get y is equal to 0.31 times 15 plus 29.76. And use your calculator here, and you're going to get 34.41 million people. So, a lot of people, they keep growing quite a bit. Got one more for you here. You can approximate, collect telephone call, charges using a linear function. Collect telephone calls, kind of same idea as cell phones back from 90s, early 2000s before everybody had a cell phone here. So we're going to write a linear equation to approximate the cost of a collect telephone call. Use the information shown on the telephone bill to create your model. So what we're going to look at here, we're still using y is equal to mx plus b. And so we need to find what that slope is. Well, I told you on the last problem that this keyword right here, rate, that's going to tell you your slope. So you already know y is equal to 0.24x. Now we just need to find out what that y-intercept is. Well, again, that's going to be the price that you pay no matter what. So for your first minute, that's going to be your 344. Okay, no matter what. If you use less than a minute, you're still going to get charged that 344. So that's going to be your y-intercept of 344, and then you just keep adding on the rate for each additional minute. That's how phone companies make their money, based on minutes. They charge you more for the first minute, and then it drops quite a bit for each additional minute after that. Then part B, to find out how much a 9-minute phone call would cost, is we're going to plug into our equation up here. But this 344 is charged for the first minute. So we have to ask ourselves, how many additional minutes am I going to need? Well, if I have 9 minutes and I've already paid for one, that's going to leave me with 8 additional minutes that I need to use at this rate of 24 cents a minute. So I'm going to plug into my equation. Y is equal to 0.24 times my additional minutes, which is going to be 8 plus 344, which is going to give me a total cost of $5.36. So once you get your equation, usually pretty easy to plug into it and answer the second part of the question. So hopefully this helps. Here's your homework, page 276, number 16 through 24, and 28 through 33. Let me know if you guys have questions. Have a good weekend, and I will see you guys back in class on Monday.